Hello everyone, welcome back to my channel. I am Shikha and today we are going to discuss about Internet of Things. In that we will take the topic of Raspberry Pi. Now, what this exactly we mean by the Raspberry Pi? Introduction to Raspberry Pi. That is, the Raspberry Pi is a compact and powerful computer that can be used for a variety of applications including media centers, retro gaming setups, and learning to code. So the Raspberry Pi 4 is the latest model featuring a powerful quad core CPU, fastest RAM, and support for a 4K displays. The Raspberry Pi is a versatile and affordable solution for hobbyists and makers. Small computer device the size of a credit card. This can be used as a web server, router, media center, and more. So equipped with the internal Wi-Fi device for the data transmission between sensors and the devices. So as we can see here, according to the description that I have given, introduction of this Raspberry Pi, that is the Raspberry, it is a compact and powerful computer that it can be used for a variety of applications, as we already told that media centers or retro gaming setups and learning to codes, we can use it. And the latest model of this Raspberry Pi is the Raspberry Pi 4. That is the latest version, which have the features of quad core CPU and the fastest RAM and the support for the 4K displays. So these are the versatile and affordable solution for the makers and the hobbyists. And these are the device of the size of a credit card. So it is very useful and handy. Now coming to the next, that what are the hardware layouts? About the hardware layouts of the Raspberry Pi. The Raspberry Pi 4, that is the latest model of the Raspberry Pi, has an Ethernet port, USB ports, a stereo output, a CSI camera port, micro HDMI ports, a USB-C port, Wi-Fi or Bluetooth, and PoE pin headers. So these, the CPU and the RAM that are located on the board, along with the micro SD card slot for the storing the operating system and data. The Raspberry Pi can be upgraded with an NVMe SSD for improved performance. So as we are telling these hardware layouts of the Raspberry Pi, for this we will just take the reference of the latest model of the Raspberry Pi 4. That is the latest model. So the features are that Ethernet ports, the usable ports that are available, that are USB ports, stereo output, CSI camera port, micro HDMI ports. So a USB-C port, also Wi-Fi, Bluetooth, and PoE pin headers. So the Raspberry Pi can be upgraded with the NVMe SSD for improved performance. So this Raspberry Pi has 40-pin GPIO headers that can be optimized as needed for wireless temperature monitoring. Wireless temperature sensors that report the readings on the 433 megahertz band can be used. So this Raspberry Pi also can be used for the wireless temperature monitoring to monitor the temperature that there are the sensors, that wireless temperature sensors that are there, that will report the readings of the weather, so that we can find out that monitor that what the weather is about to be, or on the 433 megahertz band that can be used. So the next is operating system. The Raspberry Pi operating system OS provides a graphical user interface GUI for setting up wireless connections. So users of Raspberry Pi OS Lite has and headless machines can set up wireless connections by editing the CMD line text file. The command line that was passed to the kernel at boot time can be displayed using cat proc and command line. So there are many kernel command lines parameters, some of which are defined by the kernel itself and others by the code that a kernel may be using. The display mode can be set using the video is equals entry in the command line dot text. Possible options for the display type include HDMI A1, HDMI A2, and DSI 1 and Composite 1. So these are the operating systems and how it can be used that we already discussed here. Like it will provide the GUI, that graphical user interface, and it has that headless machines that can set up wireless connections by editing the command line.txt file. So we can edit the this command line.txt file to make the connections like wireless connections and all. We can edit it according to us and implement it. The command line that was passed to the kernel at boot time can be displayed using the cat and program like these parameters and command line. So there are many kernel command line parameters, some of which are defined by the kernel itself and the other by the code. So now we'll discuss about the configuration of programming. As we told that we are using for the OS, we are using that command line parameters that are defined by the kernel, or otherwise we can use the code also. So now we'll discuss about the configuration of the programming. So the Raspberry Pi can be configured using the OS operating system customization settings. And this features the Raspberry Pi features a micro SD slot for storing the operating systems and data. Raspberry Pi runs using the Apache, MySQL, web server, and Python library, your sub files. So the data storage on the Raspberry does not use disk like hard disk on the computers. It uses micro SD cards. So Python code that reads the data from the sensor will need to know which GPIO pin to read from. So the next, in this, the software controlled radio plugged into the PI's USB port that can be used to decode wireless transmissions from the temperature sensors. Just like we are setting up the sensors to note the weather information sensors. So they will connect the PI USB port to decode the messages, the information that we received. To decode that, we will use the software control radio plugged into the PI's USB port. So in this, as we saw here, to run these the OS operating system of the Raspberry Pi, it use the Apache MySQL web servers and Python library for these. To run these and uses the disk like hard disk on the computers. It uses micro SD card too. So now the topic is like this is the last topic that we are going to discuss about this Raspberry Pi. That is the implementation of like wireless monitoring temperature system. So Raspberry Pi can be used to intercept radio messages from the temperature sensors and send them to the other servers, or read values using the REST-like request. So IoT responds based on the predetermined temperature standards by giving notifications to users via WhatsApp application on mobile devices. So the temperature and humidity log data is stored in the MySQL database, then displayed in a chart diagram in real time. The system can provide a response to reduce the temperature if there is a temperature increase in the server room. The system can be used to monitor temperature and humidity in the server room, providing real-time monitoring and a response to reduce temperature if there is an increase. So as for this temperature monitor system, the Raspberry Pi, it is used to intercept radio messages that we are getting the messages from the temperature sensors, and then we will send them to the servers, or we will use the read and we will use the values or read the values using the REST like request. So these responses are based on the predetermined temperature standards, so that will give the notifications via WhatsApp application on the mobile devices. So this temperature and humidity log data it will be stored in the form of MySQL database and then display in the chart diagram in the real time. So this system can provide a response to reduce the temperature if there is a temperature increase in the server room, as like we can maintain or monitor, and we can even increase or decrease the temperature as we will get the information on WhatsApp through these REST-like requests, or we can even share these data's messages from we will get from this temperature sensors, and we can even share it to the receiver, and this will be stored in the form of MySQL database that will display in the chart form, and so that we can increase or decrease the temperature of the server room. So the system that will be used to monitor the temperature and humidity in the server room, providing it will provide the real-time monitoring and a response to reduce the temperature if there is an increase, and if there is a decrease, we can even increase it, and if there is more, we can even decrease it as we have the data that we want. So these are the, like, from the Raspberry Pi, how we are going to implement, how it is the implementation of the wireless monitoring temperature system as we discussed. I hope you guys understand the video. Thank you very much.